Okay, so on page 5, let's look at some concept questions. We've got 2 rocks that are going to be thrown off a cliff, and they're thrown horizontally. And so definitely look for that code word in your problems, because right now that's all we're doing. Okay, maybe in 30 minutes we start throwing things at an angle, just like when you throw the football or kick a ball, soccer ball, hit a tennis ball, any kind of ball sports is usually a projectile, okay? And it says 2 identical rocks. Not that mass matters to us right now, but that would mean they have same shape, same size, same mass. But they are thrown with different velocities. They're thrown at the same time. So the time equals 0, the timer starts the same time for both. Oh, thank you. Okay. And so we start the timer the same. They're thrown from the same place. Notice your hand, the thrower, is on top of a cliff. They've already defined the positive direction for us, up and to the right, pretty standard. And then it says a few seconds after they're thrown, they're still in the air. And so notice they are at the same height, right? But not the same horizontal position. And so height is that change in y, right? It's a vertical distance. Does anyone remember the vocab word for horizontal distance that a projectile travels? Okay, range. And so the range of A compared to the range of B. So those are different. First question, will the magnitude, what does magnitude mean? Size, amount, number, right? Who cares what direction? And by the way, don't mislead yourself. Magnitude is not a variable on a physics formula chart. I've had students in the past, not yet this year, but it happens very frequently. Where's the equation for magnitude? And I say, magnitude of what? Magnitude is not a physics variable. It's not in an equation. It's just whatever the horizontal velocity is, absolute value. And so, will the magnitude of the horizontal velocity, notice they don't just say velocity, you got to be specific now. So in our write out type of answers, make sure you add in horizontal or vertical from this point on, right? Is A greater than, less than, or equal to the horizontal velocity of B? So we're comparing rock A and rock B. What do you think? So it's horizontal, so let's do the explanation. Let's do the reasoning first, and then we'll get our answer, okay? It's typically what I do anyway. So let's think, what's true about these objects in the horizontal? It's flying through the air. What do we know horizontally?
Rock B travel further than rock A in the same amount of time.
Okay, and so we know that rock B has a greater displacement or horizontal distance than A, right? Now this problem in specific, it's from tippers. I just say that so y'all kind of get a feel for it. It doesn't say if it is or isn't drawn to scale, okay? But here we do have to make that assumption that it's somewhat drawn to scale. It may not be a double relationship necessarily, but I think it's safe to say B is greater than A in terms of range. Now you said the word same amount of time. Now that's true, but how do you know? Is that an assumption or can you base it on physics? So you can think about if this was a simulation or slow motion video, the time starts for both the same. That's what the directions told us. Then if you pause the video sometime later, we're looking at those positions, right? And so in that sense, hopefully it makes sense. But let's think about vertical. Okay, we'll come to find out that time is actually vertically dependent. So tell me about the vertical information for these two.
Since they're like at the same vertical level and there's no vertical velocity for them. We can
Oh,
say
wait,
that
there's no vertical velocity?
0.
Oh, in the beginning. Okay. And so the initial vertical velocity is 0 for both. So that's the same. They start at the same top of the cliff, right? So yi and yf are the same at both points, right? What else is true vertically? What is the vertical acceleration? Right, negative g, negative 10, however, right? And it's the same for both. And so same. If we were to use a physics equation to solve for that time, and I'm choosing the second one because we don't know that final velocity, notice the height change is the same. Gravity is the same. And so tell me about the time. It has to be the same. Oh, down arrow, don't think it decreases. T squared, T, would have to be the same. And so that was a correct statement, but you got to know why, okay? The physics exam is about explaining the physics, okay? And so, yeah, same amount of time due to the vertical information. That's true. Now go back. So we know the distances in the horizontal are different. Same time, but what physics principle, what equation do we use pretty much all the time in the horizontal? Do y'all remember? Tell me what the acceleration is in the horizontal. The second it leaves our person's hand, it is in free fall. It may not be going straight up, straight down, but the only thing working on it is what? Gravity, and that's how we define free fall, right? And so it's in free fall. Gravity only affects the vertical. What's changing the horizontal velocity? It's hard because the number is 0, right? When you neglect wind and air resistance, nothing is acting on the projectile, on the object, in the horizontal direction. And so we have a constant velocity. What equation do you use for constant velocity? What's the defining equation for velocity? Can't forget our defining equations. Displacement over time. And so average, constant, initial, final, it's all the same in the horizontal, right? And so if they have the same amount of time, what kind of relationship does velocity have with that horizontal range? Is that a direct relationship or an indirect relationship? Direct. And by the way, I'm going this far because this is kind of what AP expects. You base it on a mathematical model, AKA equation, and you explain all the little pieces, right? And so there's a direct relationship between V and delta X. And so who has the greatest speed? Well, who has the greatest range? B has the greatest range. Now, careful, the question is actually asking about A. So to answer A, we'll say it's less than. Okay. So A goes a shorter distance. So it's because it has a shorter or smaller horizontal velocity. Less oomph, right? We've thrown things before. To make things go faster, to go farther, don't you have to give them more oomph? Later, we'll call that a force, right? And so the throw action, it's not a projectile. We're looking at the velocity it leaves the hand with, okay? All right, what about B? By the way, we spent a lot of time with that one. Hopefully these go quicker. What about the magnitude of the vertical velocity of A compared to B? Say again. Equal. Why equal? VYA. Oh, it's not just gravity.
There's no like extra vertical velocity velocity given to them when they're thrown.
Okay, so if we know the only thing working on them is that gravity, and it's not just gravity alone, what else depends on it? Right? Vertical displacement is the same. They said the same initial position, same final position. And so that's the same. Give me one more reason. Because you really need to consider 3 variables before you get an answer, whether numerically or conceptually. And we can use our answer from before. They have the same time. And so to find that final velocity, in the other piece you could have given, the initial velocity in the vertical was the same. And so to find that final velocity, first or third equation, most of students and adults alike, we like that first one better, right? And so if AT is the same and VI is the same, well, then final has to be the same. Okay. Now what about acceleration? Now, 2 questions. We got horizontal acceleration and vertical acceleration. This one should go really quick because we've already addressed it in the first 2. Tell me about horizontal acceleration.
Same.
It is the same. Can you tell me more? A number. 0, right? So they're both 0 for the same reason, neglect air resistance, right? And so they would be equal. What about vertical acceleration? Both -10 or negative gravity. And so it would be the same for both, okay? That one's more quick. Those are just the nature of projectiles, the nature of free fall. You didn't have to use an equation to prove that. Okay, questions on page 5. A little bit more concepts, get our feet wet here before we do some calculations. What about page 6? Another comparison. Same 2 rocks type situation, okay? 2 identical rocks thrown horizontally from a cliff, same. So think about the same picture. Rock A, they tell us, has a greater velocity at the instant it's released compared to rock B. So they're released at the same time, but we throw A greater. Now that's different from the picture, right? We said A was less. Here they're actually telling us VXA is greater than VXB. Use a coordinate system. So here's where, if they don't make the decision for you, you get to. But here they're telling you the coordinate system, down is positive, vertical direction. So that's not standard, but we got to go with it. And away from the cliff, now there's no picture, so I'm thinking of the picture on the other page. So I'm going to say away from the cliff is going to be to my right on this page, is the positive horizontal. And the origin of the coordinate system is at the bottom of the cliff. So the ground would be your 0 meter mark, horizontally and vertically. Sketch the velocity versus time graphs, plural, not just one. We have 2 objects, so we have rock A, rock B. And they even reminded you which one's faster here. And they each have 2 velocity graphs because now with 2 dimensions, the motion is independent, right? The only thing that's the same in both is time. But your horizontal velocity is separate than vertical velocity. And so just make note, horizontal, vertical. And we've got quadrant 1 and 4 for both. So let's just look at rock A. What's the horizontal velocity gonna do in rock A? Is it 0? Is it changing? Are we curving, diagonal, horizontal? It's going to be constant because the nature of horizontal, it's constant. Above or below? So they said we're going to throw it away from the cliff, and away is positive. So it's kind of going to that, it's not your standard up, down, left, right. It's that forward, backward, away and towards the cliff. And so if you throw it away from the cliff, that's the positive direction. And so we want to have a constant horizontal velocity for A, whatever timing it takes. What about the vertical velocity for A? So just A alone, when you throw it horizontally, what's the initial velocity in the vertical? 0. You don't throw it up or down. And so the only number we can say is 0. So there's a data point. And as it falls down vertically, the positive direction, we're going to have a bigger magnitude, quadrant 1, right? And how do I connect those 2 points? Curve. Think forward. Here in a little bit, no, never mind, I'm thinking of a different page. If we were to consider an acceleration time graph for the vertical, what would we want to see? For objects in free fall, tell me about the acceleration in the vertical. Constant, typically negative, but watch out. Today they define down as positive. And so if I say gravity pulls us down, and on this problem, it would be a positive value. You want constant acceleration, right? In the vertical. So how do I connect those 2 points on the velocity vertical time graph to get that constant acceleration? Graphs don't go away. If I curve it, that would mean the velocity changes are different each time. That's not a constant acceleration. So how do I get a constant acceleration on a velocity time graph? Straight diagonal line. There we go. Rather than just tell you, I want to make sure you know the why. The why is the important part. The why is where you get more points, right? Okay. Everybody good there? What about B? How would rock B look different, if any? Start with horizontal velocity.
No, I just have a question.
Oh,
Since we already established that gravity would be -10, then would the velocity be going all the way?
Well, when you say we establish gravity's negative, the only thing you can say for every single problem every single time is that gravity pulls the object down. Down is not always negative.
Oh yeah, but like because of the past page, we said -10, so like would the AP graders take points off?
Here, yes, because this problem defined down as positive.
Oh, they.
Yeah, up above it said, use the coordinate system down as positive vertical. And so when we draw our graphs, we have to follow that. If they didn't say anything at all, we get to decide. Yeah, and it's real easy, get in the habit, if they don't tell you, just show the grader what you're doing. It's an up arrow, it's a down arrow, it's a plus. You don't even have to say minus, just define one of them, okay? So that's why gravity appears to be positive. It's still pulling you towards the earth. It's just down as positive. What about rock B? Horizontal velocity. What should we see? Constant velocity again. I mean, it is in free fall. That only means you have vertical changes. And so, but this time it's slower. So we just want to come a lower. All right. It's still going away from the cliff. What about the vertical velocity? It's exactly the same. If they're released from the same position and they have initial velocity 0 because they're launched horizontally and gravity affects them the same, right? Then these two graphs are going to be identical. So I'm going to do my best. I want to have the same slope, okay? So if we think about graphical strategies, I'm going to take it a step further. You know, some of y'all are still working on redo for number 2, which had graphical emphasis. So consider this part, you know, tutoring for graphs. What if I came in here and did area of the 2 horizontal? What would area of a horizontal velocity time graph tell us? I think I heard the D word. Displacement. What specific kind of displacement? Horizontal, so this would be range. Delta X, right? And so that horizontal displacement, look at the areas. We have different areas. Does that make sense? Does it follow suit? They tell us A is going faster. Doesn't it make sense that it should go further based on the previous page? Yeah. What about area of the vertical? Now, yeah, it's a triangle, 1/2 base times height, whatever. But what's the area of a vertical velocity versus time graph? Still displacement, but more specifically, it would be vertical displacement, which sometimes is equal to the height, right? And so they have the same area if they have the same slope and same initial and final velocities. They'd have exactly the same. Wasn't it thrown from the same person on the same cliff? Yeah. So that should make sense. Good there? All right, they got some questions for us. We spent some time getting to know the problem, diving deep, dissecting, right? Which rock hits the ground first? So I didn't draw my graphs to scale, okay? Which one hits the ground first? Or let's figure out which one hits the ground first. So let's think about, what if there were numbers here? How would we solve for time? What mathematical model and variables would we consider? Time is dependent on which axis? You remember? Vertical. So, and the key to that one, think back to the balloon. To find the time, we use the vertical axis. It's equal in both columns, but it's dependent on the vertical, because it's how long does gravity take to slow you down or speed you up? And so what do we know vertically about these 2 rocks? Gravity, same. They were thrown horizontally, so initial vertical velocity is 0, same. We said their vertical displacement was the same. Our mathematical model that we can use to kind of figure out the time, kind of the same as we did on the other page, right? So VIT zeroes out. And so if our vertical height displacement is the same and gravity is the same, then time has to be the same. So to answer their question, which one hits the ground first? Maybe neither. They hit at the same time. Good deal? And moral of the story on these, y'all, these aren't the paragraph response. I know as more classes took, they're like the exam that we had last class. Some students called me over. Is this the paragraph response? Is this? We're not doing that just yet. We're going to work our way up to it. But these explain your reasoning is just give a physics explanation. You can use sentences, but mathematical models, principles, looking at relationships, what has a direct, what has an inverse, those are the things you need to talk about. Don't just say, you know, it's the same because gravity. No points for you. There's more to the picture, more to the physics than that. All right, which rock lands the farthest from the cliff? We already talked about this. The farthest from the cliff, they're saying who has the biggest range? Horizontal distance, what did we say? A, right? Graphically, I showed that with area, right? A had a greater area. And so the range of A is greater than the range of B. So maybe I could, give an area, but, I didn't really consider drawing to scale. So to relate it back to a physics principle, using this equation, right? It's the plus 1/2 AT squared. But with horizontal acceleration being 0, we just have delta x range equals your horizontal velocity times time. And we just said that time is the same. So who's going to go further? What kind of relationship does range and horizontal velocity have? Is this a direct or indirect relationship? When they're both on the numerator side, both on each side of an equal sign. Think about proportion type. Ooh, this is a big thing in physics. Let's cookie cutter this. What if everybody was equal to 1? It's called the game of 1, power of 1. I don't know what it's called. Something of 1. Everybody starts at 1. That's a true mathematical statement, right? Now time, I got to keep the same. But rock A is moving faster. So this is for A. What would the range of A be? What would it equal? Well, now I know you're just asleep. 1 times 2 is 2. Did someone say 4? Come on now. Okay, so 1 times 2, if we make this one for rock B, A has a higher speed, velocity in the horizontal, so it's going to have a higher range, right? And so this is a direct relationship. AP loves it. I can't say you get more points, but you increase your chances of getting more points when you use an equation and talk about the relationships, okay? And so range and horizontal velocity, direct relationship. So because VA is greater than B, then your range for A is greater than the range for B. Good deal? All right, show me the numbers. Let's do some numbers. If you want to grab a calculator, you can. So we're going to try number 1 together, and then I'm going to have y'all try number 2. Now, we're not going to have pages and pages and pages of horizontal launch. In the big scheme of things, these are the boring ones. These are the easier ones, okay? And so after we do this page, we'll start doing angled launches, which is actually your more real life. When you throw a ball, do we really throw it horizontally? Probably not, okay? If you went to the game last night, the physics game, the projectile game, the football game, right? Anytime, this is a baseball example, same thing with soccer ball, tennis, any sport with a ball probably has a projectile, right? Involved in it. And so notice we're throwing an object at an angle, right? So that's coming. That one gets more interesting in variability. And so number 1 on page 7, a movie stunt driver, in other words, no one gets hurt in physics land. They're on a motorcycle and they speed horizontally off of a 50-meter high cliff. No one gets hurt in physics land. How fast must the motorcycle leave the cliff top to land 90 meters from the base of the cliff where the cameras are? And neglect air resistance, okay? That didn't even need to be there. The rule is you neglect it unless told otherwise. And so pictures, okay, we're still newbies, so let's draw pictures. It helps most people. When, tests roll around and such, there's not many pictures. Typically, when I draw a picture in tutoring for a student, it helps them. So I encourage you, draw a sketch out. It doesn't have to be artistic. So here's my mushroom car, whatever you want to call it. We're going to drive off horizontally. And notice this arrow, I just draw tangent to that moment. If you think back to the balloon, what pathway is this car going to follow? Does it go straight over and then drop straight down? No, just like our rocks, it's actually going to follow a parabolic trajectory, okay? So that horizontal velocity vector is just there at the moment it all begins to become a projectile. And so what do we know? It says 50 meters high cliff, that's the vertical height. So if I call the ground 0, we know it's going to start at 50 meters. So if you like the position reference, there's your positions. Could I have also called the top of the cliff 0 and then looked at forward 50 meters down? Sure, you could change that. And the displacement, if you want to use these, final 0 minus 50, I would have negative 50 displacement, okay? Well, what about the 90 meters? It lands 90 meters from the base of the cliff. 90 meters would be there. Maybe my 0 meter mark is the base of the cliff and it goes 90 meters. I went to the right, you can go left, just it goes forward, right? And that's it. And a lot of students are like, how do you expect me to find the speed and the other speed with only given 2 distances? Where's my time? Classic 2D motion problem solving. You got to find time on your own and then use it to find the speeds, okay? And the T-chart helps. The XY data table. This really does help. It's not required, but it helps keep things separate. Before we start putting in the 50 and 90, what are some of the things that are true for all projectiles? Let's put that in there. What was true about our water balloon, our rock example? It's in free fall. Tell me more. Good. And so vertical acceleration is our gravity, and we do want to use numbers on this one. Now you said negative 10. Does it have to be negative? Should my sign convention be negative? If you call the ground 0 and have negative displacement as you go down, we're basically saying down is negative, right? And so down being negative, yeah, I want to be consistent. Gravity should be negative. If I call down positive, make gravity positive. What else is always true? What about horizontal acceleration? 0. Meaning what about my horizontal velocity? Constant. Meaning every single time, 99.9% of the time, we get to use what equation on the horizontal side? You can either use the definition of velocity, displacement over time, or it turns out to be the exact same if we use the second equation. Okay, and the 1/2 t squared zeroes out. So those are the same equations. It's just solved for something different. What's always true on the vertical? We have gravity. What else is always true? The split second it comes off the cliff, it's moving in the horizontal, but there's no vertical advantage one way or the other. So what happens vertically? Right, the initial vertical velocity is 0, okay, for horizontal launches. Now, here in a little bit, we'll start talking angled launches, and it's not going to be initial equals 0. So here's what is always true. You ready for this? The peak vertical velocity, the peaky velocity, is always 0, okay? It's just on this problem, we start at the peak, so it's initial. And then the other little bit is that big idea that time is the same in both columns. So everything I just wrote in those two columns is true for all your 2D, okay? It's true for all your 2D problems. None of that was written in the problem. Now let's add in. We know the vertical displacement. Based on my sign convention, I got to go with -50 and a horizontal displacement of 90. Is this enough? What are we looking for? What's the unknown? How fast must the motorcycle leave the cliff top? What are we solving for? The cliff top is where it all begins. So it's an initial velocity, but be careful, 2D, you've got to talk about direction. So it leaves horizontally. So we're solving for that Vx. Now, I didn't put initial because we said constant velocity, right? And so to solve it, we need the displacement, check. We got 90. We need the time. They didn't give it to me. We got to go solve for it. And so let's look at vertical information. Let's solve for time in the vertical. And so we should have enough. We know 3 numbers. What equation are we going to use to solve for time? One, two, three, 2. So I'm going to put it in vertical displacement terms. And the split second we come off, our peaky velocity is 0. And so -50 equals 1/2 of -10 times t squared. Half of -10, -5. -50 divided by -5. What do we get? T squared equals a +10. Square root it, it's more than 3. Someone get me my decimal. 1/6, okay? You could, again, show all your work, show the grader what you're doing. You could call that 3.2 and still get full points. Now don't call it 3, right? Square root of 9 is different than square root of 10. So just don't call it 3. It's Goldilocks, y'all. Not too many digits, not too few. Goldilocks, 2 or 3, okay? It's not my rule. It's just in general physics. It's a loose interpretation of sig fig rules, but have some appreciation for sig figs. Well, that time is not my answer, but now I can use it to find my horizontal velocity. And so horizontal velocity is that displacement over time, 90 meters. Gee, I wish it had been 3 even. That's okay. What do we get? Who's got my calculator? 28 point what? 46. So 28.5, we'll call it. Okay. And then meters per second. Is that my answer to number 1? A. How fast must the motorcycle leave the cliff top? Did we answer that question? Yeah. It leaves horizontal. Horizontal velocity is constant. So we found it. Okay, B, what is the speed at impact? Let me zoom in on the impact. So here's something new. We haven't done impact before, okay? Now we have for straight up and down. We're not looking at after the impact. The answer is not 0. We're looking at that last moment it's a projectile, the split second before it hits the ground, okay? And so notice, do footballs, soccer balls, baseballs, the bullet in the video, do objects hit the ground straight up and down, only vertical? Do they hit it only horizontal? Well, that's kind of impossible, right? And so it always hits at some angle, yes? By the way, that's a Greek symbol theta. In this class, it's for angle, okay? You'll see some of our equations on the formula chart involve angle. No, we don't need the angle right now on this one, okay? We will on the next problem, but it hits at some angle. And so the actual velocity, or if we ignore direction, that's a speed. This is called impact speed, which is what we're solving for here. It's neither horizontal nor vertical. Isn't it a combination of both? It's kind of vertical, it's kind of horizontal. Here's the new piece with vectors. All we've done with vectors so far is drawn an arrow and said it has direction. That's it. So now we're going to get into something like vector analysis. Vectors have components. There's a final vertical velocity, and whether you call it final or not, remember horizontal velocity is constant. Now notice horizontal and vertical by nature, X and Y, those are perpendicular to each other. Look at that as a triangle, a right triangle. Gee, if only I knew the two sides of that triangle, how could I find the impact speed, which kind of looks like a hypotenuse to me? Somebody say the P word. Pythagorean. And so we're going to be using Pythagorean theorem. And in case you forgot it, it is on the formula chart. So what I find interesting, they don't give you quadratic equation, which sometimes you can use to save a little bit of time in projectiles and 1D kinematics. There's always a workaround, typically. They don't give you quadratic, but they give you Pythagorean, okay? So a squared, b squared, those are the sides of your triangle. And so that would be VFY squared plus VX squared, and then equals that impact speed squared. So I wrote it a little different, not ABC. I'm putting the physics to it, right? And so remember, horizontal velocity is constant, and we already know this. We solved for it earlier. That was the 28.5. And so 28.5 squared, do we know the final vertical velocity? We know the initial was 0 if you go back to your table, but do I know the final? Not yet. Okay, so there's two equations that have final velocity. Y'all want to do the first or third? And everybody says the first. Why square if we don't have to, right? And although I agree with you, I'm going to force us to use them all at some point. But let's use the first equation. Where's my problem? So let's use the first equation to find that final vertical velocity. Right? Now here's where you don't want to mix and match stuff. So don't put our horizontal 28.5 here. We started at 0. And so really the final is just our -10 times the time, which we got was 3.2, I think. No, 3.16, we said. We could have said 3.2. And the nice part about the first equation, if you can use it, the sign is built in. Whatever sign you get, you should be able to use that to tell you direction. And so we get -31.6 meters per second. And negative would mean we were going down. That's what we said earlier. And when it hits the ground, isn't it going downward? Yeah, it should agree. And so now we know -31.6. Now that negative is going to square out, right? And so in terms of magnitude, it goes away. And so go on, grab a calculator, square these two final velocities, and then take the atom, and then take the square root, right? Don't forget the square root. and let me know what you get. Now, as you calculate, if you remember your basic right triangle, 3, 4, 5, you never just add the legs up, right? 3 plus 4 does not equal 5. But it kind of gives you a gauge. If we did add them, my hypotenuse should be more or less than the added. Should be less. So 32-ish, 28-ish is about 60, right? Our answer should be less than 60. So kind of just a guide for us. All right, so who calculated? What do we get? Wait, you really got a negative? It's okay, we'll talk about it. Give me that magnitude again. 30 what, or no? You got, no, 31.6, you can't. That's not the hypotenuse. You got to do the 28.5 squared with it. So square both velocities, add them up, square root that answer. Let me know what you get. Some number between 31.6 and 60. Those of you watching the video, like nobody's reaching for a calculator. I don't know the answer. I have not posted the key. It's Friday for me too. Can't do this in my head. Punch it into Google or take 2 steps to the side of the room and grab that very nice charged yellow calculator. Punch it away. Oh, what did we hear? 42 point what? 1.5. I like it. Okay, so that's between the 31, the highest side, and then smaller than the sum. And so is it positive or negative? Neither. Okay, the hypotenuse is always a magnitude. The hypotenuse is always a magnitude. So impact speed is what they asked us for. But what if they said velocity? I need magnitude and direction. I'm going to take it one step further, okay? How do you find direction? Well, it's the direction of that impact speed. And when you look at the picture, you're like, oh, she drew the arrow southeast. Southeast is generic. If I told you the treasure is in the southeast direction, would you find it easily? No, would it be helpful if I told you it was like 30 degrees southeast of here? If I gave you degrees or that actual angle, that would be helpful to find the treasure. And so with vectors, direction, sometimes it's as simple as up, down, left, right. But when you have angles, don't just say northeast, don't say southeast. Give the angle relative to the ground here, relative to your near axis, okay? And so let's do that. We'll finish it out. And so I'm adding on here. So that Greek symbol theta is our angle. We're going to solve for it. Now, look on your formula chart. You do not have to memorize sine, cosine, tan. They use A, B, and C, but I'd say SOHCAHTOA. What's SOHCAHTOA? It's just fun to say. Sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And TOA, tan theta, is equal to opposite over adjacent. So who's who? Well, in my triangle, I don't want to dirty up that other one anymore. And so if we look at our triangle, arrows, because vectors have arrows, here's my theta. Opposite would be that final y velocity. Now the next two, both are adjacent, they're both touching theta, but the long side opposite, the 90 degrees, is your hypotenuse. And that's my actual impact speed that we just solved for. And the one that's not the hypotenuse is your adjacent, and that's going to be your x component. Good deal? Use the ABC if you want, but just so you know, it is helpful to draw the triangle out for each problem, okay? So how do we find that angle? Well, we know all sides. Pick your favorite. Sine, cosine, tan, pick your favorite. Now I'm going to go on and use tan. Textbooks, as you thumb through chapter 3.5, I think I had on there, they actually don't have a projectile chapter. It's considered an application of forces. So it's one section in chapter 3. But I don't know why I said that. Oh, most textbooks use tan, okay? Because maybe we don't know if we did Pythagorean right? Maybe we finger slipped. We don't want to extrapolate that mistake, okay? And so tan theta is what a lot of textbooks use. And so based on this triangle, it would be your opposite VFY over adjacent VX. And then I can plug in our numbers. VFY. Now, true story, it was negative, but I don't know all the math reasons, but quadrant 2 and quadrant 4, whenever you go to do tan with those, it doesn't know which quadrant you're in. So that's another reason drawing individual pictures helps, okay? So I'm just going to do magnitude of the angle. And so don't worry about that negative. And then your X is 28.5. And I really wish everybody had a calculator in your hand, because when you go to solve this, some students are going to get a number less than 1. And I'm here to tell you that's wrong. The number is not less than 1. And you might be looking, oh yeah, 31 divided by 28, that's going to be 1 point something. That's not the number I'm talking about. So this is 1 point something, right? How do I solve for theta? How do I move tan to the other side? I think I heard it. Inverse or some arctan, right? Inverse tan, you hit the second button on your calculator and then hit tan. And you'll put in that, whatever it is, I'm just going to keep it here, 1 point something, or you can type it in at that point. Here is where some students are going to get a number less than 1, and I'm going to go, no, that's wrong. You punched it in right. Does anyone know the secret? It's got to be in degree mode. Degree, degree, degree. If you're in radian mode, you'll get the wrong answer, okay? And I empathize with you right now. I will try to tell you before the next exam, make sure your calculator's in degree mode. Make sure your calculator's in degree mode. Hey, friend next to me, degree mode, degree mode, degree mode. Somebody's going to forget, okay? Somebody's going to turn in their exam and then send me an email later. Miss Earhart, I took the exam and it was all in radian mode. Oh, I empathize with you, I do. Okay, make it your habit over the next 2 weeks as you practice, make that mistake now so you don't make it on September 29th. Good deal? Okay, degree mode, degree mode, degree mode. What mode? Say it louder. Everybody? Louder? It's Friday, okay. So now, hopefully somebody has a calculator. What angle does this car hit the ground at? Now, the way we have it drawn, yes, it's going to be a number, 0 to 90, right? Okay, we know that. What angle does it hit? And yes, thank you. That's good. 27.9, we're just going to call it, oh, 47.9. So we'll just call it 48 degrees. Now is that quadrant 1, 2, 3, 4? Well, my arrow is kind of pointed south, but it's 48 degrees above the ground. It's going to hit the ground based on the picture we drew. It's going to be above the ground, right? Adjacent to the x-axis. And so that's how you would find the angle. Now, Ms. Earhart, why'd you do that? They didn't even tell us to do that. Well, here I'm gonna have y'all do the next question and look at question B. What's the velocity, magnitude, and direction? How do you give the direction of an impact speed? Theta. All right, questions on that first one that we did together? It was a lot, I know. All right, I do one, you do one. Number 3, a ball thrown horizontally. We got about 10-ish more minutes. Do A and B work together, and we'll check answers before you leave.